Lesson 64, complex fractions and complex numbers. We've learned that a complex fraction is a fraction that contains one or more fraction lines. For example, if we have a fraction in the numerator as well as a fraction in the denominator, that would be an example of a complex fraction. All right, so as a reminder, let's put that a complex fraction is any fraction that contains more than one fraction line. Okay. In order to simplify complex fractions, we would simplify the numerators and simplify the denominators by adding like terms. And then we need to multiply the entire fraction by the reciprocal of the divisor, or the reciprocal of the denominator. So we've done examples like this before. We're just going to kind of review. So let's look at one example. We have a plus 1 over b plus x. When simplifying complex fractions, you want to start with the most complicated part first. Obviously, this a out by itself, we will leave until the end. We want to simplify 1 over b plus x. We're going to take our complex fraction and we're going to break it down even further by simplifying either the numerator and or the denominator. In this fraction, our numerator is simplified. Okay, 1 is as simple as it gets. And it's over 1 over b plus x. So we want to simplify, first of all, this 1 over b plus x. Now we know this x is over 1. So what we want to do is find a common denominator to add them. Okay, a common denominator between b and 1 would be b. All right, 1 stays the same, and our x becomes bx. So now our denominator term was simplified to be 1 over bx. So now I can take this whole fraction and rewrite it as 1 over 1 plus bx over b. All right, in order to simplify this complex fraction, we do the numerator divided by the denominator, or the numerator times the reciprocal of the denominator. So our numerator is 1. We have 1 over 1, and we're going to multiply by the reciprocal of our denominator here. The reciprocal would be b over 1 plus bx. Right, if I multiply across, I get b over 1 plus bx. That b over 1 plus bx has now taken the place of this entire term here, and we've simplified it completely. So now my problem looks like this. I have a plus b over 1 plus bx. So now we just need to simplify and add these fractions by finding the common denominator. All right, a, of course, is over 1, and the common denominator between 1 and 1 plus bx is going to be 1 plus bx. So I have 1 plus bx. Now this a, we're going to have to multiply by 1 plus bx. So we're going to have to distribute this a in. So I'm going to get a plus abx. And of course b stays the same. We can't combine any like terms in our numerator. And so our final answer is a plus abx plus b over 1 plus bx. So what we're doing is we're taking the most complex part of our complex fraction and simplifying until our entire thing is simplified completely with one numerator over one denominator. All right, let's do another one that is a little more complicated. All right, the next example, we have a over x plus 4 all over 1 plus b over x. All right, what we want to do first is we're going to simplify our complex fraction on the right, 4 over 1 plus b over x, by simplifying the denominator. In the denominator, I have 1 over 1 plus b over x. I want to find a common denominator. My common denominator is going to be x. So now I have I have x over x plus b over x. Right? So now I can replace this fraction. We have a over x plus 4 all over b plus x over x, because I've simplified this fraction here. Now, in order to simplify that complex fraction, we do the numerator, which is 4 over 1, times the reciprocal of the denominator. Okay, the reciprocal of the denominator is x over b plus x. So we want to go ahead and multiply across, and we get 4x over b plus x. So now I've taken this problem and simplified it even further to say a over x plus 4x over b plus x. All right, now we need to find a common denominator for x and b plus x. All right, so what we're going to do, our common denominator is going to be x times bx. All right, so we have a over x and 4x over b plus x. Our common denominator is going to be x times b plus x. Well, what did I have to multiply x here by in order to get x times b plus x? I had to multiply it times b plus x. So I'm going to have a times b plus x. Yes, in this case, you do need to distribute. All right, so my distributed is going to be a plus b plus ax. All right, here, I multiplied b plus x times x to give me x times b plus x. So I'm going to do 4x times x, which gives me 4x squared. All right, so now I can combine it all together to be over 1 denominator. All right, so my numerator is ab plus ax plus 4x squared. And it's all over x times x plus b, or b plus x. All right, I'm going to have you do one more example on your own. This example needs to be done in your notes, and we will check it in class. Here's your example. We have b plus 1 all over 1 over z plus 2m. All right, that needs to be simplified completely. Go ahead and pause the video, and when you've simplified it, hit play to continue the lesson. All right, the next thing we're going to talk about is complex numbers. We've talked about complex numbers before. These are when we are dealing with our imaginary numbers and all the i's. So it would be helpful if you had a note card with your i's written on them to go ahead and get them out. But in these complex numbers, we're just going to be simplifying using either the distributive property or some of our rules that we've used. All right, so we're just going to work through a couple examples, and then I'll have you do a few on your own. The first one looks like this. We have the square root of negative 2 times the square root of negative 3. Now remember that a negative inside a square root symbol means that we pull out an I. So I could rewrite this as the square root of 2i times the square root of 3i. All right, then we're going to go ahead and multiply our like terms. Well, the square root of 2 times the square root of 3 is the square root of 6. I times I becomes I squared. Well, we know, or we can look up, that I squared means negative 1. So this is really negative 1 times the square root of 6, or we could say negative root 6. Okay, so we're just simplifying complex numbers. All right, let's look at another one. In this next one, we have 4i cubed minus 2i to the 4th plus 2 times the square root of negative 9 plus the square root of negative 3 times the square root of negative 3. All right, let's go ahead and simplify each term before we combine like terms. All right, we have 4i cubed. All right, I cubed is the same as negative I, so we could rewrite this as negative 4i. I to the 4th is the same as 1, so we do negative 2 times 1, which is negative 2. All right, then we have 2 times the square root of negative 9. Now remember, we can take out that negative and replace it with an I, but the square root of 9 is 3. So now I have 2 times 3, which is 6i. All right, and then over here, I have the square root of 3 times the square root of 3, and they're both negative. So I can replace those negatives with an I. All right, the square root of 3 times the square root of 3 is going to be the square root of 9. And we have I times I, which is I squared. Now, the square root of 9 is 3, and I squared is -1, so 3 times -1 would be -3. So this whole term simplifies to -3. Now we can combine like terms. Remember, in combining like terms that when we write them in standard form, the real number comes first and the imaginary number comes last. So we're going to combine our real numbers. -2 plus -3 is -5. And then we have -4i plus 6i, and that will give us plus 2i. All right, we're going to do one more before you do some on your own. We have 4 plus 2i times 3 minus 2i. In this case, you're going to have to use the distributive property, and then you're going to have to simplify. All right, so if we distribute, I'm going to distribute this 4 into both terms first. 4 times 3 is 12, and 4 times -2i is -8i. All right, so that takes care of my first term. And I have 2i times 3 and 2i times -2i. All right, 2i times 3 would be plus 6i. And then we have -2i times 2i, which would give me -4i squared. All right, before we combine like terms, we can simplify that I squared. Remember that I squared is the same thing as -1. So I have -4 times -1, which would give me a plus 4. Now I can combine like terms, keeping in mind that in standard form the real number comes first. All right, so we have 12 plus 4, which is 16, and -8i plus 6i is -2i. All right, so we're just simplifying complex numbers in various problems. I'm going to give you 2 examples, and I want you to go ahead and work them out on your own, and we will check them in class tomorrow. Please make sure you do these problems. The first one, we have I to the 4th minus 5i cubed minus 3 times the square root of -3 times the square root of -5. Right, that's the first one. The second one is 3 plus 5i times 4 minus 5i. Right, so go ahead and solve those example problems, and we will look at them when we come in back into class.